All right, so in this video segment, we're going to talk about how ESCs and motors work together, how the motor actually spins, and use that property of magnetism to explain some of this. So in this diagram here, you can see there's an ESC off to the right. This is not my diagram, but it works pretty well. ESC off to the right, and then we have a motor represented here in the center. In kind of a cutaway view, we have the rotor on the outside edge here with the pink and purple permanent magnets along the edge. And we have the stator in the center with all those different T-posts all kind of wrapped around with the wire, the copper coils you see in the motor, which are actually plugged into the ESC. That's where those motor leads go. Inside the motors, they go to the different coils wrapped around the stator. And so what happens is if you remember magnetism in general, like there's the north and south poles of magnets. And so if you have two north poles and you put them together, they'll repel each other. If you have a north and a south pole and you put them close to each other, they'll attract each other. So you have the traction and repulsion forces. And so what happens is the motor basically has all these electromagnets in the center. Okay, so when you run current through a wire that's wrapped around something that's like ferrous, like a ferrous metal, like a nail on those science experiments, or there's lots of other ferrous materials, but if you run it through the wire that's wrapped around a ferrous material, it'll become magnetic. And since the ESC can control which way the current is flowing and things like that, it can change whether these coils are on or off, whether they're north or south, et cetera, et cetera. And since the permanent magnets on the outside of the rotor can never change, okay, if you look in this picture here, there's north, south, north, south, north, south, same thing over here. They're always the same. They don't change, right? But if we can control the electromagnets on the inside of the motor on the stator, we can attract or repel from the center those magnets on the outside. The center is where it's bolted onto your drone, so that part's not going to move, and the outside is connected to the propeller. So if we can attract and repel the magnets on the part that's connected to the propeller, we can effectively start to make the propeller spin. Okay? The ESC can switch these on and off fast enough to time them right that they will attract and repel the outside permanent magnets and start kind of pushing them in a certain direction. Right? Pushing and pulling, I should say, in a certain direction. Once it starts doing that fast enough, the motor is spinning, your prop spinning, and you have your power to fly your drone or plane or whatever it is. Okay, the ESC can be switched over to spin the motor the other way, just like we looked at a minute ago in the other video, and that's totally fine. The ESC doesn't really care, but it can time things right based on the electricity flowing from the ESC through the motor in order to spin the motor slow or fast and clockwise or counterclockwise. Let's look at the dot cam for a minute and see if we can explain this again a little bit more in a hands-on method, which may help some of you understand the concept. Okay, so we're going to go ahead and turn the dot cam on there. Okay, good. Let's scoot this over a little bit so we have some fresh drawing room here, perhaps. Back this up a little bit. Okay. All right, so here's our little motor we looked at earlier. Okay, I can pull this apart. We can see inside all those silver permanent magnets, and we can see the stator, which has all the electromagnets. Okay, so if I were to draw this, let's try to draw this kind of diagram here we saw just a second ago. So we'll draw a circle. I'm just going to make this real simple. Okay, let's say this has 1, 2, 3. Oops, I'm not drawing right here. There we go. Let's try to make it symmetrical. Come on, Duke. So we'll have this around here. Here's our coils. So each of these are electromagnets. Okay, there we go. That looks okay on the dot cam. Let's try to get a little bit closer maybe. There we go. And then we have our outside. There's a perfect circle. Look at that every time. And we have our magnets along here. Geez, that was a very good magnet. Okay, try to fill these in a little bit. Wish I had different colors of Sharpies. That would be helpful, but oh well. Okay, so we have our permanent magnets along here. I'm going to try to stage at least one of these so we can show how this would work. Okay, obviously this is not drawn exactly to scale or anything like that, of course. All those disclaimers, apply all the disclaimers to my drawing. Okay, so the permanent magnets we can say again are north, south, north, south, north, south. Now, we probably wouldn't have two norths next to each other, so let's add another little one in here, south. Okay. All right, so what's happening is the electromagnets inside here in the state are connected up to the ESC, right? So we'll kind of draw 1, 2, 3. We can draw those going out to the ESC, which is off screen. Sorry about that. Okay. There's our ESC controlling everything. Okay. And we have the rotor like this, right? And so let's say this is a north and this is north and this is a south, like we have labeled here, right? So what we want to do to get the motor to kind of spin, right, is to let's focus on this piece of the stator right here. Okay, so if this is the north and this is the south, we want the motor to spin this way. So we'll kind of put an arrow. Let's see so you guys can see it. An arrow like this. When the motor to spin this way, right? That means the rotor is going to spin that way. The center part stays stationary because it's the stator. It doesn't move. Okay, we want it to move this way. So that means in order for it to move this way, okay, if we look at this one right here, this piece of the stator, it's going to be basically doing things very quickly, right? Faster than we can really see it. But it needs to be first at kind of a north, right? In order to repel or push on this south, say go away south, okay? Go away south. And then as this spins, right? It needs to change into a south, okay? So it can attract this north right here. Okay, now those arrows are a little hard to see. Let's try to zoom in a little bit. So first it's a north, right? And it's going to push on the south, push it away, and say go that way south, go away. And then as it gets closer to the north, this is going to change into a south, the electromagnet is. It's going to say, hey, north over here. It's going to attract the north towards it. And then as this passes by this, it's going to change to a north again. It's going to say, hey, get away from here, just like it was before. Okay? It has to attract and repel and attract and repel and attract and repel. It does that super quick as this is spinning around. The ESC takes care of that. Okay? Takes care of that switching. There we go. Takes care of that switching on each of these pieces of the stator. Okay, so as it switches back and forth and back and forth and back and forth on all these different ones at the same time, okay, it attracts and repels these permanent magnets, which forces this to turn, okay, faster and faster, right? And if we're going to spin this way, same thing, just in reverse, basically. Okay, so hopefully that helps a little bit to understand how the motors actually work. Okay, and again, these are representation of these coils here in the center, these little T pieces, and then we have the rotor, the permanent magnets there on the outside, these little black pieces there. Okay, hopefully that helps understand how the motor is actually working and spinning. Let's jump back over to the slides here for a second. And actually, we're going to break here until the next clip. Thanks.